Hello, we're Group 6, Los Tigres, Ilona, Laurence, Cornell, Hira, and me, Tom. And today we'll be presenting our analysis on the use of artificial intelligence at the front line of healthcare, with a specific focus on AI in triage and mental health. This project explores the current landscape, future potential, and critical ethical considerations of integrating these powerful technologies into patient care. So, what do we mean by AI at the front line of healthcare? We're focusing on specialized, domain specific large language models, or LLMs, designed to serve as the first point of contact for patients in a triage setting. This includes augmenting emergency services and general practitioners. A significant and nuanced subset of this is the application of AI in mental health, which has its own unique set of considerations. Our objectives for this report and presentation are to explore the current state of AI triage technology, visualize what future applications might look like, analyze the benefits as well as the ethical challenges and potential biases, and finally, propose concrete recommendations and mitigation strategies to ensure this technology is developed and deployed responsibly. To understand the opportunity for AI, we first need to look at the traditional triage system. Triage is the process of sorting and prioritizing patients based on the urgency of their medical needs to allocate resources effectively. This process typically begins with a 911 dispatch center, where trained professionals make an initial assessment. From there, emergency medical services, or EMS, take over at the scene, providing initial care and transporting patients to the most appropriate facility. Upon arrival at an emergency department, or ED, medical staff conduct another rapid evaluation, often using a standardized system like the Emergency Severity Index to determine the priority of care. The overarching goal is to identify life threatening conditions and use limited resources to maximize positive outcomes. Less urgent situations are handled at clinics or by general practitioners, but the core challenge of prioritization remains. This traditional system, while established, faces significant challenges. It is heavily reliant on human judgment, which can be prone to error, especially in high stress environments. Systemic issues like ED overcrowding, staff shortages, and the overuse of emergency services by certain patient groups exacerbate these problems. The consequences of these challenges are serious. Human error and bias can lead to incorrect patient classifications, misdiagnosis, and inefficient resource allocation. Overestimating severity wastes resources, while underestimating it can lead to delayed critical care and, in the worst cases, preventable harm or death. This is where AI, particularly recent advancements in LLMs, represents a paradigm shift. Unlike older rules based systems, modern LLMs can understand the nuances of human language and provide conversational, context aware responses. When fine tuned on medical data, these models can support symptom interpretation, risk assessment, and preliminary triage before a patient even speaks to a clinician. Several companies are already making significant strides in this space. Informatica fuses medical logic with natural language processing to offer a sophisticated symptom checker and triage tool used by health systems globally. It assesses patient reported symptoms to recommend the appropriate care pathway from self care to emergency services. Hippocratic AI is developing an LLM focused on non diagnostic tests like preclinical triage and patient intake, designed to augment rather than to replace healthcare providers, with a strong emphasis on safety. And while not yet used for triage, Google's MedPalm 2 has shown near expert level performance on medical licensing exams, signaling the future potential for highly advanced, medically grounded LLMs in healthcare. The mental health space has also seen the emergence of conversational AI tools like WISA and Wobot. These platforms use frameworks like cognitive behavioral therapy to provide real time emotional support and mood tracking. While not diagnostic, they function as valuable mental health triage assistants, especially for those who face barriers to traditional care. Looking forward, our grand vision is for domain specific LLMs to be seamlessly integrated into healthcare systems. These models, continuously updated with the latest medical knowledge, could serve as a first line triage service, gathering symptom data and even vitals through smart devices to provide initial diagnoses and care recommendations.
Some of the key benefits of AI in triage include improved access to care, where LLMs can bridge geographical, temporal, and financial gaps in healthcare access, providing immediate input in emergency situations and reducing barriers to initial assessment. Others include optimized resource allocation, enhanced diagnostic accuracy, risk identification, and the integration of advanced capabilities, which allow the LLM to facilitate integration with specialized algorithmic tools that have demonstrated superior diagnostic accuracy compared to practitioners in specific scenarios. Some ethical considerations to look at when we look at this system as a whole is making sure we hold true to utilitarianism principles, such as making sure that the AI deployment in triage maximizes the most positive health outcomes across the entire population through efficient resource allocation and increased access to care. Looking at it from a Kantian ethics perspective, we are emphasizing respect for human autonomy and dignity and requiring transparent AI systems to ensure that patients are always aware that they are interacting with artificial intelligence and providing informed consent. And finally, from a virtue ethics perspective, we are shifting the focus to the character and the intentions of the AI so that developers and healthcare providers, we expect virtues like honesty, compassion, and justice, and system design and implementation. All three of those together ensure that we have beneficial and a virtuous AI system, autonomy and virtuous practice, ethical outcomes and autonomy, which in the middle equate to our ethical AI and healthcare triage system. Looking at bias, fairness, and the governance models, there's two things to take a look at. One, the LLM bias and fairness challenges, where LLMs such as this can perpetuate or amplify existing biases in clinical data sets and disproportionately impact underserved communities. We also want to look at the challenge that different demographic groups may express symptoms differently, challenging the creation of universally fair assessment criteria. And lastly, we want to make sure we look out for historical healthcare disparities that may be encoded in the training data, leading to algorithmic discrimination. Some of the governance models we really want to focus in on are self-regulation, allowing industry-led standards with limited enforcement mechanisms. So making sure that we monitor that. Also, the public regulation aspects, making sure that government mandated frameworks, making sure that they do not lack the technical specificity needed to balance the model. And then lastly, co-regulation, which is a collaborative approach combining industry expertise with regulatory oversight. Using a multi-layered governance approach is necessary, including diverse training data, making sure that there's regular bias audits, human oversight, and clear accountability frameworks. Looking at those regulatory frameworks, there's two types of models we want to look at. One is the European Union approach, and the second is the United States approach. In the EU, they have the EU AI Act, which classifies healthcare AI as a high risk, which requires robust risk management, human oversight, and transparency. While in the United States, they have a more decentralized regulatory model with the FDA oversight of medical devices, but it has limited authority over many AI applications. In the EU, they use a health data space, which establishes a framework for health data sharing based on principles of patient control, secure access, and interoperability. While in the US, it relies mainly on executive orders on AI safety and innovation, which provide general principles, but they don't address specific healthcare mandates. And then lastly, in the EU, there's a high-level expert group, a panel that emphasizes trustworthiness through technical robustness, privacy, transparency, and accountability. While in the United States, it relies on a system of state-level patchwork of legislation. And what we want to also make sure we understand is that the EU takes a comprehensive, centralized approach to AI governance, healthcare, while the US relies on a more fragmented system spanning federal agencies, state laws, and self-regulation.
Building on those ethical considerations, we can now look more closely at the concrete risks and bias challenges involved in AI triage systems, particularly in emergency and mental health care. First, accuracy is critical. A single misclassification can lead to serious harm, either by delaying urgent care or by misallocating scarce medical resources. Large language models introduce a unique risk here. They're known to hallucinate, producing confident yet medically incorrect outputs. When those outputs influence care decisions, the consequences can be life-threatening. Then there's explainability. Many LLMs function as black boxes, making it difficult for clinicians to understand the reasoning behind a recommendation. This lack of transparency weakens both clinical trust and legal accountability. In settings like mental health triage, where decisions are deeply personal and emotionally charged, explainability isn't optional, it's essential. Privacy is another key concern. These systems often handle highly sensitive data, yet many operate outside traditional regulatory frameworks like HIPAA or GDPR. For example, apps like Wyza or Wobot explicitly state they're not covered entities. This opens the door to questionable data sharing, unclear consent practice, and potential misuse of behavioral data. Informed consent is also evolving. Many users don't realize they're interacting with AI, or they assume it's more capable than it is. In high vulnerability contexts like crisis mental health, users need clear, proactive information about what the system does, what data it uses, and when a human professional will step in. And finally, there's the issue of accountability. If a triage error leads to harm, who is responsible? The developer, the healthcare institution, the clinician who relied on the system? Current legal structures aren't equipped to answer this. Without clear models of liability, patient safety is at risk. To mitigate this risk, a robust governance framework is essential, one that aimed ethics, risk management, and compliance from the outset. We recommend establishing independent oversight bodies, regulatory or multidisciplinary review boards to assess high-risk AI systems before deployment. These should evaluate fairness, safety, transparency, and ensure post-deployment audits and public reporting. Next, we need to promote fairness in data governance. That includes using diverse representative training data and involving underrepresented communities in oversight. Documentation of data sources and fairness metrics should be mandatory for regulatory approval. We also call for clear liability frameworks, inspired by the EU AI Act. This means defining how responsibility is shared between developers, institutions, and clinicians, so that when harms occurs, there's clarity and resource. On the operational side, several safeguards should be built in. Bias audits and demographic validation should be routine to ensure equity across gender, race, language, and socioeconomic lines. A human-in-the-loop model should always be in place for high-risk decisions. AI suggestions should support, not replace, clinical judgment. Systems must be explainable. Clinicians should be able to trace the logic behind a recommendation, whether through input rationale, summary explanations, or decision tree. Informed consent must go beyond disclaimers. Users should actively understand they're interacting with AI and what that means for their data and care. And finally, a privacy-first architecture is essential. Data collection should be minimized, anonymized by default, and subject to regular legal compliance audits. Together, these recommendations are designed to ensure AI in healthcare is not only effective, but also ethically aligned, safe, and accountable.
In conclusion, AI triage isn't a far off future concept, it's already here. Just last week, it was announced that South Korea has begun transitioning its emergency number to an AI assisted system. This system analyzes calls to help prioritize the most urgent cases, and it has the capacity to process hundreds of calls at once. This is a powerful proof of concept. Once this infrastructure is in place for emergency response, it can be expanded to other triage services. However, as we've discussed, this expansion must be handled with care. significant caveats remain around bias, privacy, liability, and explainability. The path forward requires a concerted effort, with centralized regulatory bodies enforcing clear common standards. With these critical guardrails in place, we believe the use of domain-specific healthcare LLMs can be profoundly beneficial for patients and healthcare systems worldwide. Thank you so much for watching.